The 10th question from alternating current, more precisely transformer. Okay, the transformer is there consisting of 300 turns in the primary and 150 turns in the secondary. So N1 is 300 and N2 is 150. That means a step down transformer has been given. So primary to secondary, voltage would lower while the current would increase. The output power is 2.2 kilowatt. So that's the power output, which is 2200 watt. And the current in the secondary, that's 10. So we need to calculate the input voltage and current. What I will do is that this output power can be denoted as 10 multiplied by V2. So that's going to be V2 into I2, and you get V2 is equal to 220 volt. All right. So now I have the secondary current is 10 ampere, which has been given. The secondary voltage is 220 volt. I need to calculate the primary voltage and the current. And you see, since N1 is to N2 is 2 is to 1, so voltage would also be following the same pattern. That means the primary voltage would be 440 volt. And the voltage would be double, but we know the current would get halved. So 10 ampere has to be 5 ampere. Search the option. The voltage would become 440, the current would become 5 ampere. Option number 1 is the correct one. So with question number 10, we've already done 1/3 of that. Now let's move to the question number 11. The 11th question has been derived from electrostatic. It says a uniformly charged ring of radius 3a and total charge Q is placed in the xy plane centered at origin. A point charge Q is moving towards the ring along the z-axis. That means it's moving towards the center of the ring and has speed v at z equals to 4a. We need to calculate the minimum value of v such that it crosses the origin. Fine. So it's something like this, say. I'll just try to show with the help of a figure here, and it goes something like this. So this is the ring, and the radius of the ring has been given as 3a. It's in the xy plane, and the total charge that the ring possesses is Q. That's distributed in this way, that's Q. And at z equals to 4a, so let's try to make that as well, z equals to 4a. Fair enough. Z equals to 4a. So somewhere here from the center, z equals to 4a, and you could see that if that's 4a, 3a, the calculation part, the examiner is kind enough to give you an easier calculation. And here there is another charge which is Q. We need to calculate the minimum speed so that it crosses the origin. Quite obviously, this charge which is in motion has to face the repulsive force. So to cross the origin, that means the velocity decreases due to retardation. So when it comes about the minimum speed, that means by the time it crosses the origin, the speed is just equal to 0. So that is the condition which has to be maintained. Now, I think it can't be easier than this. It's simply an energy equation, equating it because of only conservative force acting. The mechanical energy is constant, and therefore it will be 1/2 mv square plus Q into kq by 5a. So that's the potential due to the ring at this point, kq divided by under root of y square plus r square multiplied by the test charge. So that's going to give the total potential energy, and that when we equate, by the time it reaches the origin, the kinetic energy would be just equals to 0, because that is the condition we are satisfying. And yes, when I write about the potential energy, that will be Q into kq divided by 3a. That's only the game. Now you need to put the value of K as 1 by 4 pi epsilon naught. You solve it and you would land up with option number 4 as the correct option. Fine, now let's proceed to the next one. Thermodynamics, that is from where the question has been set. And it says that n moles of an ideal gas with constant volume heat capacity Cv. So that has been given. Now you need not worry whether it's a monoatomic, diatomic or polyatomic. After all, Cv has been given. And it undergoes an isobaric expansion by a certain volume. We need to calculate the ratio of work done in the process to the heat supplied. So work done to the heat supplied is going to be Nr delta T is the work done, the heat supplied is Ncp, and that would be Cv plus R delta T. I think that's fine, and that will be R divided by Cv plus R. However, this given option is not matching with any given option, and this question has been brought from the website, the official website of the organizing committee. So here we leave the answer up to this point and we would say none of the given option is matching, and this is the correct option to the best of our information and knowledge. Let's move to the next one.